So can you hear me, everyone? Yes. Perfect. So hello, everyone. Thank you for coming to my talk. So I'm going to briefly present myself. So my name is Gabrielle Botbol, and I am an offensive security advisor for a Canadian banking cooperative. And alongside my full-time work, I freelance and offer various cybersecurity-related services, such as training and consulting. And in addition to my professional activities, I'm very involved in the cybersecurity community. And so in recent years, I have also been recognized with awards such as the top 20 women in cybersecurity in Canada and Woman Hacker of the Year in 2022. So today, I wanted to share with you my journey in AI, and specifically AI in the Android system. So what I want to share with you today is how, as a pen tester, I trained myself, but also how I explored and tested how AI was going to change my profession and how it was going to impact Android and, of course, Android security. So first, let's have a quick reminder on what is Android. So Android is a mobile operating system which is based on a modified version of the Linux kernel, and it's developed by Google. And the most used language for Android app is Java. But since 2019, the official language is Kotlin. And so the Android architecture is divided into 5 main layers that you can see on the screen. So now that this is all cleared up, we're going to chat about the pen test of the Android app. So what is Android app pen test? So along with mobile pen test, it is a type of pen test that it is part of the list we usually provide as pen testers. So it's different from other pen tests because most of the time we get an executable that we need to analyze. So why is this important? So here you can see 2 articles that I invite you to read. The links are going to be in the resources that I will provide at the end. You will have like a QR code to scan, or you can just take a picture. You will have a link as well if you don't trust QR code. But to summarize the first article, it's about Gold Pickaxe, which is a sophisticated malware for Android and iOS that uses social engineering tactics to deceive users and trick them into scanning their face and identity document. So this malware is suspected of using this information to generate deepfakes or to illegally access banking services. The other article is also very interesting, and in summary, it highlights the discovery of a new Android malware family called Autolycos, which has been downloaded more than 3 million times from the Google Play Store. And so this malware was embedded in at least 8 applications, and some of which stayed available on the Google Play Store for several months, even after being reported to Google. So, to my knowledge, there hasn't been major breach caused by AI directly malfunctioning or being compromised in Android application. However, what we're seeing are significant privacy issues when installing Gen AI apps, and more concerning, cyber criminals are increasingly using AI to enhance their attacks. And so, additionally, AI apps themselves are going to pose security risk. So, for example, it could lead to like some vulnerabilities were found to popular AI apps like Perplexity. We are going to talk about this a little on later. And this could lead to data theft and account takeover. So really what's interesting today is how AI is being weaponized by bad actors, and also how AI applications are creating new attack surfaces. So here are some figures. They come from Zimberium's Global Mobile Threat Report that was published in early 2025. And so I really think that all of these are quite alarming. But to mention only 2, I would say that first, according to the report, 61.2% of Android devices were running out-of-date operating systems during 2024. So now, what's even more critical is that over half of these devices, about like 35%, were it could have been avoided because they could have the update, but they were just not updated. So, so the other 25% of the device were too old to be updated. So they could not be updated. And this is really problematic because phones are expensive today. And when people can't update their older device, well, it creates a gap. And security is not something you should sacrifice. And so I think it's really problematic because we have to use phone, we have to use smartphone every day. We do everything with smartphone. So and I will go. I have a next slide actually about what so much we do about our cell phones. And also another really important and typical of the AI era we are in today is that the AI usage grew by 160% in apps on enterprise devices. So what is interesting is that 12% of these apps are related to finance. So I think it's really important to stress that out. To go further with AI security risk, I wanted to also present these figures taken from the report Top AI Security Incidents by Adversa. I also have the link for you in the end. And so as you can see here, prompt injection is the new skill to learn. And so I'm going to explain briefly a few terms here because they are essential in AI security. So prompt injection is basically when someone with malicious intent tricks an AI system by sneaking harmful commands into their input. And so you can think of it like the developers are going to give the AI a set of rules to follow, but bad actor can try to give new instructions to override those original rules. So this could lead to jailbreaking, for example. And it happens because the AI can't always tell the difference between the legitimate instruction it's supposed to follow and the sneaky ones that are hidden and that the user input. Hallucination is when an LLM makes up information because they just don't know the answer of what you're asking. And so, yeah, that's pretty much it for this one. So finally, as I quickly mentioned before, we cannot deny the place that smartphones have today. They are much more than simple communication device. They play really a central role in many essential daily activities, whether it's for managing our finances, whether it's for browsing the internet, whether it's for interacting on social media. It's real gateways to the world. And so an unsecured smartphone, it's not just a risk to your personal information, but it can also be a gateway to broader attack on your financials and social life. So they contain sensitive data, and they could have, if it's compromised, it could have devastating consequences. So now let's see how AI is actually built into Android and mobile devices. So there are essentially four main ways this works. So first, we have what's called embedded or on-device AI. So that is where AI models run directly on your Android devices, hardware, like without needing to send any data to the cloud. So this is on-device. Second, there's cloud-based AI. So it's also known as enhanced AI. And this is where your device sends data to the cloud servers for AI processing, and then you get the result back. And third, you have many Android AI features that will use hybrid approaches, and it will combine both on-device and cloud-based AI to get the best of both worlds. And finally, what's important to note is also that Google provides various AI tools and framework to help developers integrate AI into their Android app. So before diving into this slide, I wanted to briefly mention the difference between AI and Gen AI. So traditional AI will analyze existing data to make prediction and classifications and answer questions like what is this or what will happen next. And so generative AI will create entirely new content from learned patterns. So it's going to produce original text, images and code, and also other material based on user prompts, so what you will ask it. So on this slide, I wanted to show where we can find AI on a mobile device, because this is not something you can see right away. So the meta category, user interface and interaction, will encompass all AI features that directly facilitate how users will communicate with and control their Android device through various input methods and interfaces. The meta-category core system intelligence, it covers the foundational AI systems that will manage the resources, the security, and overall system optimizations behind the scenes. And the meta-category content creation and media will focus on AI features that enhance creative expressions, media consumption, and generation on Android devices. And finally, the connected experience meta-category covers AI integration that extend beyond the device itself to connect with external services. So this can be IoT devices, this can be health monitoring systems, and so on. So before the attack surface, I wanted to mention briefly the difference between the ML security risk and the LLM security risk. So as you probably know, OWASP has published multiple top 10s, and they published the top 10 for ML and the top 10 for LLM. And so when I started to get into AI red teaming, which is another of my current passion as a red teamer, I was wondering about the difference between these two top 10. And at some point, I thought that the OWASP top 10 for LLM was more focused on post-deployment, and that the ML one was more focused on pre-deployment. But however, now, I realized that if an attacker is able to fingerprint a model or get a model file, they could actually use the attacks like the one in the OWASP top 10 ML, which is after deployment as well. And also recently, I found this table on Ria Mashewari's repository. And so you will also have it on the slide, on the resources. And so it highlights the differences between the same both top 10s. And here we can see, for example, that the attack she mentions could be both done post-deployment and pre-deployment. So now that we have seen this, what does the Android attack surface look like today? Well, it is the sum of its traditional vulnerabilities and a whole new set of threats that are introduced by the integration of artificial intelligence. So the traditional vulnerabilities would be any app on your phone, the core Android software itself, how your phone talks to the outside world with Wi-Fi, with Bluetooth, with cellular data, the specific permissions the apps are granted, or just simple human error like a phishing or a scam or installing a malware, for example. And so today we can say that the AI layer will add new dimensions to these existing areas and expands the attack surface on various levels. So the AI-enhanced application will introduce new ways to be tricked or exploited. So, for example, as we mentioned before, prompt injection or adversarial examples. And so for the AI data flow over the networks, because AI models communicate with cloud services, and so they will receive update. So the network is even a more critical point than it used to be. And so here we can have data leakage, and we can also find model tampering. And also the AI models and their inference engine, so this is the software and the hardware that runs the AI, they reside within the phone system. So now a traditional OS vulnerability could be exploited to directly steal the AI model's intellectual property, tamper with its operation, or extract sensitive data it processes. Then the AI-driven data inference means that AI can figure out private details about you from data that seems harmless. So I really want to stress this out. So if you have an AI photo sorter, and it has only permission to see your images, you know what could go wrong? Except it can deduce your location, and it can deduce who you are based on social circles, for example, or on facial recognitions, and even without explicit location or contact permissions. So we have the permissions that control this, but we don't know what the AI is going to do. And so the AI model itself, in other words, the AI brain, we can say, it becomes a direct target because it can be targeted with model theft or backdoors. And so the AI training data is a new vulnerability point, and it could be targeted with data poisoning. And finally, the AI development and deployment pipeline can also have vulnerabilities. So they can exist in the tools, in the processes, or in environments where the AI models are built. So where they are tested and where they are deployed. And so this could be compromised even before the AI reaches your phone. So to summarize, we could say that the Android attack surface is like a complex interplay of hardware, of operating systems, of applications, network, and the entire life cycle of embedded and cloud-connected AI systems. And so each of these elements are opportunities for attackers to exploit it. And also something worth noting that we will see implicitly through the presentation is that, in essence, AI security demands a shift from a purely technical lens to a more holistic socio-technical perspective, because it requires new tools, new skills, and also to have a continuous adaptive approach to risk management and reporting. So what about APIs? So as you know, a lot of developers are going to use APIs to develop their Android applications for various reasons. So you can see them on the screen. And finally, today, APIs are also used for tasks related to artificial intelligence. So machine learning, inference, computer vision, speech recognition, and natural language understanding. So to go a little further about APIs related to AI, I wanted to give an overview of how AI changed Android APIs. So, you know, AI has really transformed how APIs work in Android apps. So I'm going to walk through the main changes. So first, Google realized that developers needed easier ways to add AI features to their apps. So they created brand new APIs for this. But there's another interesting element. It's that Android itself had to change at the system level. So they introduced something called the Neural Network API, which is basically a way for apps to talk directly to the specialized AI chips that are now built into many phones. So now, one of the biggest shifts has been that this move from cloud to what we call edge processing, as I presented before. So in the past, if you wanted to use AI features, your app would send data to Google servers, process it there, and then send the result back. But now, a lot of this happens on your phone. So this is supposed to be better for privacy. Not that I'm saying it is supposed to be better for privacy, because your photos and voice recordings are not supposed to leave your phone. So essentially, AI didn't just add new features to Android, it fundamentally changed how the whole AI API ecosystem works. So what does this mean for us as pen testers? Well, there are a few elements that we can take into account. So you can see some of these elements on the screen, and this is only for the application layer. But these changes also add potential vulnerabilities on the OS framework. So, and also the hardware layer. So for example, is privacy actually respected? Does the data actually stays on the local device? And does it go to the cloud later on? What happens if we try adversarial inputs? Can we fool face recognition? Can we fool text recognition? And image classification models. So now that we have seen how AI impacts API, let's see the difference between traditional APIs and model APIs that handle the AI functionality. So first, let's talk about what they're actually designed to do. So traditional APIs, they're pretty straightforward. So they handle basic operation like pulling data from a database, processing a payment, or managing user account. Model APIs, on the other hand, they are specifically built to tap into AI models and give you intelligent productions or output. So now the type of data they work with, it's also really different because traditional API will use traditional data like JSON or XML formats, and it's predictable and it's organized. But models APIs, they are more flexible. So you can input image, you can input audio files, you can input text or even videos, and they'll give you back things like classification or generated content. Also, traditional APIs, they're doing relatively simple tasks. So, which are database lookup, as we say, data transformation and everything. But model APIs, they run more complex tasks. And so they use mathematical operation using neural networks. So this leads to another big difference, which is the resources. So traditional APIs, they are generally lightweight and fast, but model APIs will need more resources and sometimes special hardware. So another difference also is predictability. With traditional API, if you send the same input, you always get the same output. It's really deterministic. But model APIs, they can be probabilistic. So especially with generative AI, you might send the exact same input twice and you will get different results. So for example, a traditional API might be send your location and get back weather data, send payment details and get a transaction status. So model APIs, it will work differently. You will send an image and you will get what objects are detected in it. You can send text to get a translation and you can send audio to get the transcribed text. So even error handling is different because traditional API will give you clear errors such as invalid input or server done. But model API will probably give you confidence scores or tell you the prediction is uncertain. So the bottom line is this. Traditional API are like efficient data processors, while model APIs are more like having some sort of assistant that can understand and make decisions about your data. So when you are pen testing an AI-enhanced Android application, each phase of the traditional methodology gets significantly expanded. So for more details, I also made another comparison that you can find in the resources I will provide. But in the reconnaissance phase, we have a few things that change. We will basically need to identify the AI system architecture to map the endpoints and to analyze the models we find, including the input and the output formats. And it also changes a few things for the dynamic analysis and static analysis and the report phase, of course. We will see a little more what happens for this specific topic in a few slides, but the bottom line here is that AI doesn't replace your methodology. It kind of layers on top of it. So each phase now has specific AI components that will require new tools, new techniques, and sometimes new skills as well. So you're not just testing an app anymore, you're testing the app and the AI model that lives in it. So this typically adds, I would say, 30 to 50% more time to your full pen test engagement. So before getting into the threat modeling framework, which is dedicated to AI, I just want to make a quick reminder on what threat modeling is. So threat modeling, it's the process to identify, understand, and address potential threats to the security of a system, an application, or an infrastructure. So it's a process that can be carried out by different security professionals. And so depending on who is doing it, the process will be different. So for example, some companies will have a dedicated team to threat modeling, but it can be done also before a pen test by pen testers themselves. This is something that I do myself. So there are various frameworks for threat modeling in traditional cybersecurity. So we can, for example, mention Stride or PASTA. But when AI arrived, these frameworks were not enough. And on the screen, you can see that the OWASP AI threat model that aims to provide a more comprehensive framework for this specific topic. So it has 3 types of threats: the one during development time, the one through using the model, and the one by attacking the system during runtime, so in production. And it also identifies 6 types of impact and for 3 types of attackers, of attacker goals. So as you probably know, attackers have 3 main objectives related to the CIA triad. So they call it disclose for the confidentiality, deceive for the integrity, and disrupt for the availability. So for the disclose category, the impacts are hurt confidentiality or train test data, hurt confidentiality of model intellectual property, and hurt confidentiality of input data. So for the deceive category, the impact is that it hurts the integrity of the model behavior. So in other words, users and systems rely on AI decisions, so of course, wrong decisions could cause real harm. And finally, for the disrupt category, the impacts are hurt availability of the model, disrupt disclose non-specific, non-AI specific assets. So for the defense strategy, they develop various controls that form a summary of how to address AI security. And so there we find AI governance to implement governance processes for AI risk application. So it's conventional technical IT security control, since an AI system is an IT system. And data scientists also should apply data science security control, but risk-based. So the aim is to minimize data and to limit the amount of data in rest and in transit. And finally, to control behavior impact, as the model can behave in unwanted ways by mistake or by manipulation. So now that we have seen how we can threat model this new AI risk, I wanted to introduce you a very useful tool for us as pen tester, which is the OWASP AI testing guide. So this is a guide that was created to help professionals test AI systems. So we can think of it as a comprehensive playbook for ensuring that AI is reliable, secure, and behave ethically. So the guide outlines a robust suite of tests, including data-centric validation, fairness assessment, adversarial robustness, and continuous performance monitoring. And so on the screen, you can see a visual that I created to show how we, as pen tester, can use this guide. So it will, of course, be in the resources that I will give you in the end, if you want to have a look. But it covers attack vectors, testing phase, arsenal high-value targets, and also sample exploits. So finally, we can say that in terms of AI security perspective, as pen tester, we are looking for various things. We are looking for high-risk findings, which could be embedded API keys or secrets in model weights. Training data samples that are accidentally baked into the model. An encrypted model that would reveal some business logic. Poor input validation that could lead to crashes or buffer overflows. Model version info that maps to known vulnerabilities. Model-specific attack vectors, which could be model extraction, like can you copy or can you use the model elsewhere? Can you fool the model with crafted inputs? And can you also reverse engineer what data was used to train it? And does the model show also unfair bias that you could exploit? So also I wanted to make a table of the various possible tools, and of course I also wanted to mention AI enhanced tools that can be used for a pen test. So on the screen you have various tools split in 3 categories: the traditional tools that we use for Android application pen test, the AI enhanced tools that we can use for Android application pen test as well, and the tools that can be used to pen test AI. So one specific tool that I wish to mention is Android Meda. So this tool is an LLM tool which is designed to deobfuscate Android app code and find vulnerabilities. And it has been created by Vaibhav Agrawal, who works for Google. So now, how do we proceed for the static analysis? So we have, of course, to check the manifest and the strings XML files. And we can also enumerate database, and you can find, of course, some tools on GitHub that can help you for this purpose. And of course, we need to check for sensitive data. So for AI enhanced app, we can search for AI model and configuration files, and we can analyze them. And to go further on this, I shared in the resources an article on how to integrate custom PyTorch model in an Android app that was done by Gabrielle Mongaras. And this way you can have an idea on how developer will integrate AI in their code. So now I wanted to provide a reminder on how to check the code, because I will show some examples in the next upcoming slides. But to check the code, you can use JADX or APK tools. And this tool will decompile the APK and will offer some level of deobfuscation. So for JADX, you just need to launch the command you see on the screen, and you're good to go. And for APK tools, you can also use this command, and it will all put everything in a folder, and it will have the name of your app, and you will get similar files to what you see on the screen. Similar files and folders. So once you have the source code, you can search for keywords such as HTTP, HTTPS to identify API endpoints. And additionally, you can look for functions or classes that will handle network requests and responses. And also, the Android manifest file in the application's APK package will contain metadata about the application. And so it will also have the declared permissions, the services, and the activities. So you can look for permissions related to network communication, which would help you to identify API endpoint. Sorry. And finally, you can analyze the application JavaScript file to identify API endpoints. So it's worth checking there for AI APIs endpoint, because they could look like something you can see, something like this that you can see on the screen. So now I want to present an app that I created. So as you probably know, the number of AI-generated mobile applications on the market will increase significantly in the coming years. So indeed, with the company that provide tools to build an application in just a few minutes with AI, so we have both businesses and individuals who will be able to publish their applications in the wild, just like that. And so recently, Google also launched Opal, which is an AI app builder. So whether it's for commercial or personal purposes, these applications that are based on things like vibe coding and produce rapidly will, of course, have security problems. And a few days ago, I read an analysis by Veracode that highlighted this specific issue. I think I put the link in my resources. If I did not, I will put it. So indeed, the analysis mentioned that AI-generated code introduced security vulnerabilities in 45% of cases. So when given a choice between secure and insecure coding method, so what does this mean? It means that the researchers, they presented AI model with coding scenarios where they had to choose how to implement a functionality. And they found out that when given a choice between a secure and insecure method to write code, GenAI model chose the insecure option 45% of the time. So that gives us some work as pen testers. So to simulate this, which is already existing and which is a growing situation, and to demonstrate this in this talk, I wanted to try building an application using this type of process. And even though a few platforms offer applications in Kotlin, we can still create application quickly with the help of generative AI. So what I wanted to do was demonstrate just how fragile this is in terms of security, which is why I'm going to present 2 examples of vulnerabilities that I inserted into this app. So this way you will be able to see the risk of AI-enhanced application and, of course, applications coded with AI. So the first example is for the static analysis phase. And in a few slides, I will show you another example with prompt injection that can be done during the dynamic analysis phase. So here we have the static analysis example. So the app as I created is called Oracle. And so I decompiled my APK and I was able to get all the files, including the model file that was built with TensorFlow. So it's the TF Lite files that you can see here. So here with just a strings, so one of the first command we learn when we do CTF, we were able to find an API key. So here, strings is the job for this specific demo, but if you wanted to do a more comprehensive analysis of a model file, you could use an app like Netron. So Netron is a graphical viewer for neural networks, and it will help visualize the model's architecture, the layers and connection, and it can sometimes reveal metadata or layer names. And also you get a visualization, sorry for the French accent. And so also for a very deep dive, you could also convert the TF Lite file into a human readable JSON format. And so you have tools like flat buffers to JSON that will do this for you. And so this would expose all internal details, including any custom metadata fields. So I'm going to go a little faster because I see it's almost time. So here, this is a traditional vulnerability that you can have, hard-coded secrets. This is from injured Android CTF. You probably all know how to grep, but you can. I think it's really useful to do this. And I added a link to my resources on various tips on how to grep. And as you know, the dynamic analysis part, so you will intercept traffic. So these are the things that you can check when you are doing the dynamic analysis. What's nice is also to try to find and identify API endpoints. So on the screen, you can see what it could look like. And it can be efficient to use a role list. And for AI API endpoints, as we saw in the static analysis, they often follow the same design pattern that common API use. So this is the prompt injection I mentioned to you. So this is a classical example from the Oracle app I created. And so the chatbot is really, really happy to give us its API key. And so in a real context, of course, it's more subtle, and sometimes we even need to interact a little more with the chatbot to get what we want. For the curious minds who want to discover a new attack vector, it is highlighted in this research paper from researchers of Monash University in Australia, and it's called the Smart App Attack Framework. And so you will find it in the list of resources I provide at the end. I'm not going to explain it because obviously I don't have time, but it's so interesting that it would require a full talk about it. So I have summarized it in a visual form, and you will find it in the resources. So one other important thing I wanted to mention is that traditional Android app Pentest is not dead. Woohoo! So in this slide, I used another research that shows that traditional vulnerabilities can still be found in AI apps. I don't know if any of you read a paper that was done by AppNox, but they were able to find classical Android vulnerabilities in the DeepSeek Android app and the Perplexity Android app. So this is really concerning because this is not just because they found numerous issues, but because they represent a lack of basic app hardening, insecure default, and almost no resistance to reverse engineering or controlled environment attacks. So this kind of raises the question of how today we find ourselves in a dilemma thank you, between, it's been here since the beginning of IT. So we have to marry speed and we have to marry security because people want things in production for yesterday. So even though we've been asking ourselves this question for a long time, it's even more pressing today because we are in the AI era and everything is going even faster. So I hope that all the time we save by automating our task, we will be able to invent solutions that we have no longer to chase for security, but instead we will anticipate risk. And so I wanted to quickly mention all the standards and frameworks that we need to take into account when we are doing a pen test. You can see them on the screen. And so today we also need to add standards for AI and some for security. And also I wanted to do a quick mention of trustworthiness. It includes AI safety. So in other words, trustworthy artificial intelligence refers to artificial intelligence that all stakeholders can trust throughout its entire life cycle. So to achieve this, it must be aligned. So it means that it should be lawful, it should be ethical, and it should be transparent. And also explainable and robust. And so, for example, when we test a model for an adversarial attack, we are checking its robustness. So this determines how well the model can handle slight changes to its input without producing a different output. On the other hand, bypassing safety measure with prompt injection will test the model's alignment. So I'm not going to go further on this. I just wanted to say that this is why AI pen test isn't just a technical process anymore, but more a holistic and socio-technical one. So I wanted to conclude on the attack phase by giving a general tip. When I do my pen test, I really like to use checklist because it gives me a way to stay on track and to make sure that I cover as many aspects of the target as possible. So the top 10s are always a nice thing you can add into your list. And these are all basic checks. And also every context is different. So in this AI era, we have to be even more careful. And the traditional approach isn't enough anymore. So we also need to test mobile vulnerabilities, AI vulnerabilities, and API vulnerabilities. Lucky for us, all of these have a top 10s. So you just have to customize your checklist. It sounds easy, but so when you do traditional Andrea pen test, the report stays the same. So I have to wrap it up, but it should look like with what you see on the screen. And for AI vulnerabilities, the scoring is different. So we can use the AI VSS score, and it was published recently by the OWASP. And just because I cannot, and I have to be done, this is the famous QR code that you can have to get the resources, but you can also take a picture, so you don't have to scan something shady. Thank you very much for coming.